With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, we are given with a question, and the question says, in column 1, a system is described in each option, right? And corresponding time period is given in the column 2. We have to match them. So first question, a simple pendulum of length L oscillating with small amplitude in a lift moving downward, right? So lift is moving downwards with a retardation of g by 2, right? So since the gravity is also acting in this direction, so there would be total acceleration, that is g plus g by 2. So that would be equal to g 3g by 2, right? And since, I'll write this here, since we have time period to be equal to 2 pi root over of L by g effective, right? So from here for A, t would be equal to 2 pi root over of L 2L by 3g. Right, so our answer would be 2L by 3g. That is this one. This is for A. The second question, a block attached to an end of a vertical spring whose another end is fixed in the ceiling of a lift stretches the spring by length L in equilibrium. Its time period when lift moves with an acceleration of g by 2 is what? Lift moves up, right? So lift is moving. This is a lift. We are hanging it, right? This is moving with g by 2. There is a gravity that is acting downwards, right? Since KL would be equal to mg for this block, right? So this implies that k by m would be equal to g by l, right? So what we can write is t to be equal to 2 pi root over of for this particle, right, or block, this would be m by k. So that would be equal to 2 pi root over of m by k is L by g, right? So our answer would be 2 pi root over of L by g. That is this one. This is for B itself, right? Now, next question. The time period of small oscillation of a uniform rod of length L smoothly hinged at one end. The rod oscillates in a vertical plane. So it oscillates in a vertical plane. So T would be equal to 2 pi root over of I by mg d, where so d is the distance from the center of mass, right? Since for rod, right, like at the one end, the moment of inertia is ml square by 3 by, this is mg. Since from center of mass it is L by 2, so from there we can write this to be equal to 2 pi root over of, since m and m gets cancelled, this power and this L gets cancelled. So we have 2L by 3g again, right? So for this also we have 2L by 3g. So that is C for this, right? The last question, that is a cubical block of edge L and specific density rho by 2 is equilibrium with some volume inside water filled in a large fixed container. Neglect viscous force and surface tension. The time period of small oscillation of the block in vertical direction is what? So it is in equilibrium with some volume inside water filled in a large fixed container, and the density is rho by 2, specific density, right? So for the particle in water, that time period is equal to m by rho a into g, right? So that would be equal to 2 pi. The mass would be density, that is rho by 2 into volume, right? So the area into length. So rho a g, correct? So this rho and this rho gets cancelled, this area and area gets cancelled. So we get 2 pi root over of 2L by g, it is 2L by g, right? So for this is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.